In the last video, we learned the commands call, jump R, load R, and store R in Today, we are going to put our skills to work with recursion. Here is a program to calculate the factorial of a number in Python. Notice how it gets an input and calls a function to calculate the factorial. This function uses recursion, so it has a base case and a recursive call. Finally, it returns our result. Let's see this function at work. We can write the same program in assembly language. Notice how it also takes an input and makes a call to a recursive function. Now let's remind ourselves how factorial runs in Python. We can easily calculate that factorial of 3 is 6. But what is Python doing below the surface in its assembly code? Let's walk through our factorial program to find out. First, we'll read register 1 and we'll set that as 3. Next, we'll set register 15 to be 42. Next, we'll call R14 and 4, so we'll place line 3 into register 14 and jump to line 4. Now we are checking if what is in register 1 is equal to 0. It is not, so we will jump to line 7. We'll store what is in register 1, which is 3, in the memory address in register 15, which is 42. Next, we'll add 1 to register 15, and we will store what is in our register 14 into the memory address of register 15. Next, we'll add 1 to register 15. We'll add -1 to what is in register 1. We will call R14 4, so we will save line 13 in register 14 and jump back to line 4. Now is what is in register 1 equal to 0? Well, it's 2, so no. So we will jump back to line 7. We will store what is in register 1 into the memory address now in register 15. We will add 1 to register 15. We will store what is in register 14 in the new memory address of register 15. We will add 1 to register 15. We will add -1 to what is in register 1. And again, we will call R14 and 4. Now we perform the same steps until we reach 0. Now we see that what is in register 1 is equal to 0, so we will move down to line 5. We set register 13 to be 1, and we jump to whatever is in register 14, which is 13. We jump to line 13, we add -1 to what is in register 15. We load our register 14, register 15, so we are taking out what is in the memory address now in register 15 and putting it into register 14. Next, we add -1 to register 15. We load R1 and R15, so we are taking what is in the new memory address of register 15 and putting it into register 1. We'll next multiply what is in register 1 and what is in register 13 and place it in register 13. Next, we will jump to what is in register 14, which is 13. We will do the same procedure as we did before, adding -1 to register 15, loading what is in register 15's memory address into register 14, adding -1 to register 15, loading what is in register 15's memory address into register 1, multiplying what is in register 1 and register 13 into register 13, and then jumping back to what is in register 14, which is 13. We will do this one more time. And now we will jump to 3. In line 3, we are to jump to 19 in the RAM, and that tells us to write what is in register 13 as our output, which is 6, and then our function halts. As you can see, it is fairly difficult for a human to follow an assembly program. This is why we do most of our programming in user-friendly languages like Python and use a compiler to translate user-friendly languages into more machine-friendly languages like assembly.